Very good evening and warm welcome to all the eminent dignitaries, invited speaker, panelists, my dear colleagues, and students present today for the webinar on entrepreneurship in aquaponics in this Zoom platform organized jointly by Techno India University West Bengal in collaboration with the institution's Innovation Council, which is a Ministry of HRD initiative. So without further ado, I would first like to call upon Professor Dr. Avijit Mitra to deliver the keynote address for today's webinar. He is a research director of Techno India University, West Bengal. Over to you, sir.
Am I visible? Am I audible?
Yes, sir, you are audible and visible.
So, good evening to everybody. It is a privilege on my part that I have been asked to tell something in the inaugural part of the seminar. And it's really a startup type of thing where I believe that the initiative should come from inside of the candidate, and the profit is the tertiary result. First, there should be some initiative, then there should be some application-oriented approach, and then finally we get the benefit cost ratio, or what you tell BCA, to finally get the result. But I have seen many of the students reading fisheries or did PhD in fishery, but they don't feel any interest to keep a small aquarium in the house. I have seen many of us doing big consultancies on forest, on ecology, on environment, but we don't feel any interest to keep a small pot of plants and try to grow it and make some experiment in our own roof, or within a small balcony in our house. So that's very important, that you should have that initiative, some application-oriented approach. Then will come, and finally then you get the result and transmit it to the other candidates. That's very important. And also I believe that this type of seminar, although I have seen quite a lot, but after the seminar is over, I have seen that not very fruitful things usually take place. It's like a seminar which goes all through the year, and but I believe that since it is a startup side type of things, some project work should be implemented by some of the and that should be taken. The initiatives should be taken from the administrative point of view, so that some of the project works may be given an award to encourage it, and then only it should have a real value. Otherwise, we are just
I think there is some network issue with Professor Mitra. So just kindly bear with us. I think it will be fixed soon. Unfortunately, we lost connection with Professor Mitra. So just let's wait for a few more minutes and hope he will join with us soon. So unfortunately, because of heavy rain, I think Dr. Mitra won't be able to join us further. So he told us to go ahead with the next part of the program. So we hope that we will be able to hear him in our next session, which is on 4th July. So so now it's time for the much awaited expert talk on entrepreneurship in aquaponics by our distinguished speaker, Dr. Saurav Dhakta. So Dr. Datta is currently working as a project officer at the Indian Institute of Biosocial Research and Development, West Bengal, India. He was a former research assistant at the Directorate of Forests, West Bengal, India, for study on invasive alien species of West Bengal. He has also worked with the Directorate of Forest Department, West Bengal Research Wing on projects involving carbon sequestration and biodiversity surveys to assess the effects of climate change. He was a PhD research fellow at the Indian Council of Agricultural Research, Central Research Institute for Jute and Allied Fibers, Biotechnology Unit, Barakpur, India, where he worked on the project entitled Development of an Efficient In Vitro Micropropagation Protocol for Production of Healthy Propagules in RAMI as planting material for enhanced productivity at sustainable scale. The work included plant tissue culture and molecular biology techniques. He did his MS as a student assistant from Max Bergmann Centrum for MBZ, Dresden, Germany, in the lab of Professor Dieter Schönweber, where he worked on cell culture and scaffold handling. He has 19 publications and 3 book chapters to his credit. So over to Dr. Datta.
Thank you, Dr. Pritam. I hope I'm audible.
Yes, you're audible. Yeah.
Yeah, okay.
Yeah.
So,
slides. Yeah.
So I'm sorry, there is some cultural events going on here outside, even though it is pouring cats and dogs over here in my place, but I hope I'm audible and I will be able to shed some light on this futuristic farming technique, which is aquaponics. So aquaponics, we have all heard about it. We have all seen people working with it. We have seen videos about it. We have seen this in movies and in futuristic movies, in the post-apocalyptic era where people cannot grow any food, so they turn to hydroponics and aquaponics. So what is aquaponics? So aquaponics is when we are bringing in 2 compound words. It's aqua and ponics. So aqua is coming from aquaculture, and ponics is a scaffold or a structure which is used to grow vegetables and agricultural products for sustainable, it's a sustainable system, it's a sustainable farming system. So I'm Saurav Dhakta, and today we'll be looking at all the various types of aquaponic systems, how they work, and what is the principle behind it. So I hope my slide is visible to everybody.
Yes, it is visible, Dr.
Okay. Thank you, Dr. Pritam Mukherjee. And so today we're going to look at aquaponics. So as I told you, it is a compound word. Now, I'm sorry. So it's a compound word, and it is made out of 2 parts. So the first part is aqua, which is referring to aquaculture. So aquaculture means raising fishes in a controlled environment. So we know what is fed to the fishes, and what is the temperature, what is the pH, and how the fishes are thriving, if they have any kind of diseases, and if not, if they are of good health. So that is aquaculture. And ponics. So ponics, this word in Latin, it means to grow in a environment which is not of natura. So that means it can be a scaffolding or a mechanical structure which we have created, and it grows on that. So what happens basically is the fishes they eat their fish food or whatever feed is given to the fishes, and they produce a lot of ammonia. Now, this ammonia, it tends to remain in the water. So most of us will be having an aquarium at home. So when we have an aquarium at home, we observe that the water getting filthy, the water getting dirty, the water getting tinge, hazy. So that is ammonia buildup in the aquarium. So now what happens is we reroute this water to the plants. Now, what the plants does, there in between, there are some bacteria, some nitrifying bacteria like Nitrococcus, Nitrosomonas, and Nitrobacter. What they do is they filter the water, they take out the ammonia from the water, and they convert it into nitrites, which get converted into nitrates. Now, these nitrates can be absorbed by plants. So these plants, they take up the nitrates and they make the water safe again, and the water is recycled back into the fish pond. So what happens is the fish get a very healthy environment, the plants get their nutrients. So it's a win-win situation for both the plants and the fishes. So what is the science behind it? The science is very simple, it's the nitrogen cycle. And we all know that when an organism takes in food, it excretes, and then via ammonification, ammonia is released into the soil. And this ammonia, it undergoes nitrification from nitrifying bacteria like Nitrosomonas. And what happens is this nitrite, ammonia gets converted into nitrites. Now, nitrites is not a stable form, so it gets further converted into nitrates. So nitrates are very inert and they are taken up, they are assimilated by the plants, and the plants can happily stay with the nitrates. Now, why do the plants take nitrates? The plants require some macronutrients and some micronutrients for their well-being, for cell division, photosynthesis, and all the other enzyme activation. For that, they need this nitrates. So they need a lot of nutrients. So the major macronutrients are NPK, as we know, the nitrogen, the phosphorus, and potassium, and they also need other micronutrients like iron. So these are how the plants survive. So in the aquaponics cycle, what happens is the fish, it produces the waste. It eats the feed and it produces the waste. Now we have some microbes and some worms which break down the ammonia, the waste, which is in the form of fish feces or ammonia, which has been released by the fish gills, and it breaks them down into nitrites. Now, once these are broken into nitrites and they reach the plants, they are again broken down into nitrates by the bacteria, and they reach the plants, and these plants then absorb the nitrates and they filter the water and then return it back to the fish. So this is like mimicking a natural system. So when we are mimicking a natural system, it becomes sustainable. So we don't have to provide any fertilizer, any foliar fertilizers from outside. So so what we were looking at the fish feed, which goes into the fishes, and then the fishes, they release their feces through ammonification. This feces get converted into ammonia. Now the ammonia has the stored nitrogen. Now these nitrogen, the bacteria which is present in the fish tank or in the plant bed, they convert the ammonia into nitrites and nitrates, and these nitrates again get assimilated for biomass formation in the plants. So this is the basic principle of this aquaponics. But how does it happen, and what are the techniques that are done? So we're going to take a look at the various techniques. So basically, this is a setup of aquaponics. Now in aquaponics, we have a tank. For example, as you can see here, we have a tank with food and some fish, which may be tilapia. So it's a very viable fish for aquaponics because it does not mind overcrowding, and it has a good growth span. And then when the fish poop or the fish feces that come out, they undergo ammonification, and the ammonia is again, the water is sucked by the pump. We have a pump system, and this pump transfers the water to the bed above or beside, which is a bed containing the plants. So now in this plant system or the media, there are bacteria which convert the ammonia into nitrite and nitrate, which can be assimilated by the plants. And then over here, they have shown a bell siphon, but there can be other arrangements also. We can have a tilting bed so that the water flows to one side of the bed, and then it is drained back into the chamber containing the fish. So what are the types of aquaponics? Aquaponics, we have basically three types of aquaponics. The three types are the bed system, so which is visible here as the drip system. So the drip system is basically you have a bed, you have a substrate media, inert media, which does not provide any nutrients to the plant. It's an inert media like coco peat or hydroton. So these are all inert medias, and you have an inert media, and on that you are growing the plants of interest, and the water from the fish chamber is supplied through a pump system. And then we have deep water culture. So the deep water culture is we basically have a tank with the fish, the water runoff from the fish tank, and this tank has all the nutrients in it, and the plants are basically floating on it on a raft system. So how is this raft system made? We are going to look at that. And you have a NFT, or the nutrient film technique. Now, this nutrient film technique is a high precision technique wherein we are using a very less amount of the water. So we are controlling the input of the water. We are controlling all the temperature, the pH at which the plants are being raised. And this is also a time-based technique where the ebb and flow method is applied on a timer basis. And we have a futuristic technique called the aeroponics. So the aeroponics, we are going to look at it, but this is not very feasible. It's expensive techniques. So we're going to look at that. And before that, we're going to look into the other three techniques. So this is the first technique which employs using a bed. So this is a small media bed unit. So what happens is we have a fish tank, and along the fish tank, we have a small media bed, and this the runoff from the fish tank, it goes into the small media beds, and these media beds, the water flows through them, and then again the water is pumped back into the fish tank. So this type of media bed, it deploys the use of various medias. So the medias like for example cocoa, we can use cocoa coir media, we can use perlite, we can use rock wool, you can also use sand media, and we can use what they're using over here is called Hydroton. So Hydroton is a media which looks like rocks but is actually clay. So these are clay pellets, and they have a lot of space in between them, so they are well aerated, and they can also grow this kind of plants. So this is the small media bed unit, and following that we have the small nutrient film technique unit. So this kind of technique is the more precise one. Precision engineering is required, and over here what happens is we are taking the water out of the fish tank, and we are deploying filters. So now why filters? Because we do not want any solid food particles or feces which are coming off as runoff from the fish tank to get stuck to our pipes, to our nutrient films. So it filters, the water is filtered, and then the water is passed on in pipes. So these are basically PVC pipes or aluminum pipes, whatever we can fabricate, and the water runs along them. So the water does not flood them, but it runs along them, and it runs along providing nutrient media to the plants on a timely basis. And then again, it comes back to another filter. So this filter, it filters any debris that might have run off from the plant or the plant root parts, the underground parts. And then again, it is pumped back into the fish tank. So this is the small nutrient film technique. And the third technique is the small deep water culture unit. So this is a more commonly used technique, is the deep water culture. So in the deep water culture, again, the water, it is pumped from the fish tank, and it leads to these tanks, these chambers, which are trays which contain a lot of water, or this nutrient filled water. And these are rafts. The rafts are made out of maybe styrofoam or some kind of materials, plastic materials, styrofoam materials, on which we have the plants, and these are floating on the beds. Now these beds, once they are floating on it, and they assimilate the nitrates and the water, it goes back into another filtration system. The filtration system, it again filters the water for any debris that might have run off from this kind of water beds, and it pumps the water back into the fish tank. So in the media bed aquaponics, the media bed aquaponics, which we have seen, the system is used for growing plants which are not very friendly to aquaponics. Like aquaponic plants, they need to have short roots. They need to have they need to be very lightweight. So if you can imagine a plate of salad, so all those things can be grown in aquaponics, like the spinach, kale, like your herbs, like your arugula, like your dill and your tomatoes, your cherry tomatoes. So you can grow all these plants in aquaponics. Now, for them to grow in aquaponics, the plants need to be lightweight. They need to be lightweight, and sometimes they need to be very hardy plants. They need to be hardy plants, and they need to be plants which can assimilate the nitrates and which are not very nutrient heavy. So if they are nutrient heavy plants, they need a lot of nutrients like rice. So we cannot grow rice very effectively on an aquaponic system. And if we want to grow them on an aquaponic system on without applying any fertilizers, no external fertilizer application, it's not possible. So we need to go for foliar fertilization in that case. But in this case, if we are not growing any nutrient heavy plants, so we can use them to grow them on bed aquaponics. So bed aquaponics, it grows plants which are really robust, which do not fare well in other aquaponic medium. So the best plants are tomato, brinjal, okra, cucumber, those types. So they grow those kind of plants. Now, the second one in the nutrient film technology, so the nutrient film technique, what happens is we need to, avoid the clogging of the pipes. So that is the major important. We need to put plants which have shallow roots. Now, if you have a plant which has a deep root, that will clog the pipe, and the nutrients will not be able to move efficiently through the system. The water won't be able to move efficiently through the system, and hence this water will not be able to come back to our aquarium properly. So we need to go for plants which have very shallow roots. If you are going for a bigger plant has deep root system. Why? It needs to support its weight on the ground. So we cannot grow very big plants in this. We can grow plants like lettuce, kale, cabbage, and basil in this kind of systems because they have a very shallow root system. Now, for the raft system, these are very durable. These rafts are very durable. They are made out of styrofoam or plastic or polymer make, and they can support plants which are of lightweight. So, like lettuce. So, lettuce can be supported, which is very lightweight, and the roots they like to remain submerged in water most of the time. So, if they are not submerged in water, if they don't like that, if the root needs a lot of aeration, so this kind of system is not proper for those kind of plants. And this raft system is best for lightweight plants like lettuce and all the salad greens, which we can imagine. So if we're going for construction of a hydroponic system, a hydroponic system will usually require certain things. So these things are, the first one is the media. So if you are going for a media bed hydroponic system and thinking about constructing one, so we go for a media. So this media is basically Hydroton, as you can see in the picture. It's Hydroton is clay particles, clay pebbles with a lot of aeration power. They have a lot of pores inside, and these Hydroton is the preferred media for inert media, which is used in aquaponics. Now, there are also other media, so you can use all the media which are used in hydroponics. So hydroponics media like perlite can be used. So you have sand, which is a very coarse media. You have perlite, you have coco peat, you have the coco coir, sorry, not the coco peat, the coco coir, which you can use. So the media has to be inert, and all this can be used as the media if we are thinking about a media, a small media bed aquaponics system. Now, if we are going to the other types of aquaponic systems, for example, the NFT, the film system, or the raft system, we have to use the hydroponic pots. So these plastic pots are hydroponic pots, and they are usually filled with the plants, and the roots they come out from the pores which are on the sides. So you can also use these kind of pots, and you can also use rock wool. So in many of the literatures or whatever videos, people deploy a lot of rock wool, and these rock wools are chopped into a square block, and the plant is planted in them. So that kind of a pot is very effective in holding these plants. And okay, the further we have the system. So the system, nowadays there are a lot of systems which are available in the markets, and some companies do sell them. So you have some integrated systems in which you can just buy your media or your pipes and your pots, and you set up the system, or you can go for manufacturing your own system. So if you have a if you take a look at the third thing, so this is the system in which the fishes are on the bottom. So that is the fish tank on the bottom, and you have the media bed on top. So the plants grow on top, and you have to, of course, deploy the usage of pumps and filters so that the water can be effectively siphoned from the filter bed, from the aquarium, from the place where the fishes are, into the filter bed to supply the plants with the nutrients, and then the water can come down to the aquarium. Um, Over here, this white thing, this is for the nutrient film technique. So for the nutrient film technique, this is a styrofoam or a polymer casing with slots cut in it. And of course, you have the way for the water to enter from one side to drain the whole chamber, and then again flow out from the other side. So this is a chamber for the nutrient film technique. And you also have pipes, PVC pipes. So as you can see, these are PVC pipes which have been chopped up, and which have holes cut into them. And in these holes, we can fit our hydroponic pots. So the hydroponic pots can be fitted into these holes, and then the plants can be planted in them, and the media can be flushed through these pipes, and again circulated back into the system. Now all this we need to do via a pump system. So most of us will be having some sort of aquarium, or might have seen some sort of aquarium wherein these kind of pumps are deployed. So for aquaponic system, we need really efficient pumps, not the aquarium pumps. So we need pumps which can filter the water, which can transfer the water. Like in 2 hours, it can transfer the whole of the water through the system. So there are two types of pumps mainly used for this kind of systems. So one is the inline pump. So the inline pump is the one where the pump sits outside, and it is a very powerful pump. It makes a lot of noise, but it is a very hardy pump. And one is a submerged pump. So the submerged pump, it is usually in the tank, present within the tank, and it is cooled. The workings of the pump is cooled by the water, so it lasts for a longer time. And the inline pump is cooled by the air. And the submerged pump has some problems, like wherein the water, it usually corrodes away the metal parts that the inline pump has. So that has some maintenance issues. But these are the two types of pump, and we need to check how much before buying the pump. We need to check the kilowatt, what is the wattage, how much electricity it's going to burn, because it's a energy dependent system. And also we need to check whether the pump is sufficient to recirculate the water present in the tank, the fish tank, within a certain stipulated time, which may be 2 hours. So within 2 hours, it should be able to circulate all of the water which is present in the fish tank. So that is one of the major criteria for deciding the pump. So here are some of the commercial aquaponic systems. So commercially, aquaponics, it is coming into the foray very in the present years, and there's a lot of people who are talking about aquaponics and hydroponic systems, and all this because there's a sustainable agriculture systems, and they are being used for the sustainable agriculture, to set up the sustainable agricultural systems, which is because due to the climate change, the climate changing happening, a lot of the crops are under a lot of stress, and also there is a lot of influx of insects and pests which are eating away at the crops. So over here, it is an organic system, and also organic is in purview. So it's an organic system wherein we do not need to apply any kind of chemical fertilizers or chemical pesticides to the system. And the plants that grow are also not growing on the soil. They are growing on inert media or in the pots. So what happens is they are also free from any kind of soil-borne pathogen which can affect them in natura. And and because of all this climate changes, there is an influx of pathogens. Pathogens have increased in natura. So these are the futuristic techniques on which we are relying for sustainable development in the future. So as you can see, these are large setups. They are the raft system, as you can see on top. Then you have the nutrient film system on the pipes, and you also have the bed system. Now, what is the price for setting up a commercial aquaponic system? So a price for aquaponic system, a commercial aquaponic system in India in a farm, it ranges between 5 lakh rupees to 15 lakh rupees. So in that you can set up a commercial aquaponic system. But then again, you might think the cost of setup is really high, but the operational cost goes down because there is no need for any kind of fertilizers or any external pesticides, because the plants are not grown on the soil, so they are not affected by the bacteria and the soil pathogens, and also they are grown in a controlled environment. So this saves the operational cost. In India, we have various companies who do supply a lot of this hydroponic, aquaponic, and hydroponic setups. So we have the Envirivo Agritech and the Arba Grow Aquaponics and the Hydrotech company from Kolkata itself. So they are operating in Kolkata, and they do have setups for hydroponics, whereas other companies like Hydrilla from Bangalore and Abun Faber the from Delhi and Mumbai. So these companies, they do supply a lot of this hydroponic setups. And for some futuristic setups, so this is a futuristic setup. Now, aquaponic system is a power dependent system. So it's an energy dependent system. We need to provide a power for the pump to work, for the pump to be able to take the water and feed it into the plant bed or the nutrient film or the raft system, wherever. And from there, we need the water to be siphoned back to the aquarium. So this is an energy dependent system. So now what people are planning to do is they're planning to use the solar energy. So once you have the solar energy, it recharges the battery, and this battery is used via a control box to control the water which is being siphoned from the aquarium into the plant beds. Also, it is using the vertical farming. So in nowadays, as you can see, we are the urbanization has grown so much. People have started making places to stay. They're cutting away forests, they're chopping away all the fields. So there is very less place for farming, for any kind of initiative farmings, and most of the land is being urbanized. So what we can do is we can go for vertical farming systems. So vertical farming systems, they provide us a place for farming, one on top of another. So that is a very futuristic technique. So this has been applied, and people are growing kale and lettuce effectively. So this is a nutrient filter system, NFT pipes, and they are using the control boxes to deliver the nutrients, and they're getting a marvelous growth of vegetables over here. So another futuristic technique is the vertical thing, the vertical system, and in this we have the vertical gardens. So the vertical gardens, there are plants, there are a lot of aquaponic systems below where the fishes are in the tanks, and these nutrients are fed to the vertical gardens. So as you can see, the garden over here, it is done on the wall of a house. So this is a very sustainable method of gardening, where when we are land strapped, when we don't have much land and we cannot expand horizontally, we expand vertically. So we are doing the vegetation, the agriculture on a vertical scale. Now, this has been also been seen in Kolkata. So this is the Times of India report. So in Kolkata, we have vertical gardens. So these vertical gardens are near New Town or under the Ma flyover. So these are initiatives taken by our government for making vertical gardens on the pillars. So these are some of the initiatives which we can see in our Kolkata. And there was one technique which I had skipped earlier. So that was aeroponics. So aeroponics is also a viable technique for aquaponics, but this technique was, it was invented by NASA, the National Aeronautical and Space Administrative Offices of the United States of America in the 1990s, wherein they wanted to grow vegetable for the people who would go to the space stations and who would work in space, and the availability of vegetable was not an option for them. So they were looking into the research of this so that they could provide them with fresh vegetables. Now, over this, what it does is it has a solution chamber, but the solution is not like the nutrient film technique, wherein it touches the roots. It does not touch the root of the plant. What happens is it has a system which releases a timely aeroponic mist. So what happens is aeroponic is where the nutrient is dispersed into air. So it sprays, it literally sprays a mist of nutrient into the root hairs. Now, once it sprays a mist of nutrients into the root hairs, the roots, they absorb all the essential nutrients from them, and it requires very less water. It requires it requires calculated amounts of nutrients, and you can grow leafy green vegetables. So this kind of technology is under much research, and it is not yet commercially viable because this is a really expensive system. You need to generate an aeroponic mist, and you need your vegetables to absorb the mist, and from that, the growth continues. This is a system of I have at my home aquarium. So over here I have a pump, which is a submersible pump. So the pump, it pulls in water, and as you can see, so this is an overhead filter. So it has a filtration over here and a pipe which delivers the water. So this filter, it's basically a filtration setup. So I have my biological filter setup over here. So this, what it does is it scrubs all the feces or the food items from the water, and the water is pumped back into this tank overhead. Now, in this overhead tank, as you can see, there are some white beads. So these are commercially available ceramic beads. The ceramic beads, they contain all my helpful bacteria. So these helpful bacteria, the ceramic beads have a lot of pores in them where the bacteria colonize, and they are present inside. And what they do is this water, this feces or the ammonia laden water, which is being transferred to the overhead filter, it gets in contact with the bacteria inside the beads, and these beads, the bacteria, they convert them into nitrates, and then again the water is poured back into the aquarium, wherein if I were to put some plants over here, they would have absorbed the nitrates, and I could have a nice hydroponic system. So what are the plants which we can use for which we can use or we can consider for an aquaponic system? Now, the plant which we want to consider for an aquaponic system has to be light in weight. It has to be lightweight because why? Because it has to be on the raft or on the media bed. If it is very heavy, it's going to sink. So it has to be light, and it has to be fast growing because we need it to grow fast, and it has to have shallow roots, otherwise it will clog the system, and it has to be very robust and more adaptable plant which can stay with less nutrients, and it will not demand more nutrients. So for a small media bed unit, when we are talking of that, we can go for plants like peas, okra, tomato, carrot, chili, and eggplant. Now again, you should be aware that the peas, the okra, the tomato, and the carrots, they are highly demanding of nutrients. So most of the time, we have such plants, there is some problem with them. Like some mineral deficiencies do occur, and that can be supplemented through foliar fertilization. And for the nutrient film technique, they grow the the low nutrient requirement plants. So like parsley, like dill, and arugula and spinach. So these people, these technique, they grows the very nutrient less demanding plants, but they can also grow strawberry, which are medium to high nutrient demanding plants. For the deep water culture units, we can consider a lot of leafy vegetables, all the vegetables that come to your mind when you hear the word salad, and all these vegetables which are very lightweight and which will not sink the raft, and these can be grown on the raft system like lettuce, and they also have a very shallow root system. So basil, kale, mint, bok choy, and cabbage, all these can be used to grow on the small deep water culture. Now about the fishes, the second the another component for the aquaponic system is the fish. Now, what kind of fishes do we consider for these aquaponic systems? So the it depends on the size of the fish. Like if the fish likes overcrowding, because it will be in a closed space, so there will be a lot of crowding. If a fish does not prefer overcrowding, so that's not going to be an ideal candidate for this kind of experimentation. And also the growth rate, because once we are thinking about the system in on a commercial scale, we are thinking about of course reaping benefits of the fish. So the fish has to grow to a certain size within a certain amount of time. So that has to be adapted. That has to be very good for the system. And also the eating habits, whether it is a carnivore, it's an omnivore, how much ammonia it is releasing into the water. This is very important. So most of the fishes which are generally used worldwide are tilapia. So tilapia is a fish which is preferred for aquaponic systems because it is very suitable for small scale aquaponics, and they do not they prefer crowding. They like to stay together. And then you have the Japanese koi, which is good for outdoor ponds. But again, let me remind you, the koi, it's not a table fish. So this is for more of cosmetic beauty. So if you have an outdoor pond, you can grow koi. And goldfish, it's a very common fish. It's very commonly available in everybody's houses. Most of the people who deploy aquarium usually like to keep goldfish. So goldfish, even though it is not a table fish, it can be grown, it can be used in an aquaponic system to grow some vegetables. Then you have the catfish, you have the jade perch, and all these other fishes. The sturgeon, even the sturgeon is a very big fish, and it is responsible for giving us caviar. So the sturgeon is also grown in this kind of techniques. Now in India, we have the barramundi or the bhetki. The carp. The carp is what we normally find in the markets. The rohu, the katla, the pona mach, which we call it, and the catfish, the singi fish, and we have the sardinella or the sardine, the koira. Then we have the Japanese koi, and you have the tilapia and the trout. So these are all the fishes which are consumed in the markets in India, and you can see the ideal water temperature for most of them. They range from around 10 to 15 degrees Celsius to around 30 degrees Celsius. So that is the water range for these people. And also the pH, and the pH has to be very neutral. So the neutral pH is optimum for both the fish and the plants. So that is around a pH of 6 to 7. And now once we are going into more acidic range, what happens is the bacteria growth begins, and it results in a fish death. And if it goes into basic, so once the pH is more basic, then crustaceans and snails is very good for them, and algae starts growing, and finally that also leads to the death of the fish. So the optimum pH for this kind of fishes is always 6 to 7, and even for the plants. Now you can also see the time these fishes they take to reach the plate size. So most of them they reach the plate size at around the time of 1 year. So we need to have a startup expenditure and we need to continue it for a year before we can see any benefits or reap any benefits from them if we are thinking about it in a commercial way. So every system has their pros and their cons. So even the aquaponic system is liable to a lot of pros and cons. So first, we are always going to see the positive side. So we're going to look at the pros. So it encompasses two types of agricultural products. So one is the fish and one is the vegetables. So it is a sustainable product. The nutrients from the fish, which are the waste products, they reach the plants and the plants assimilate it and they clean the water and they return it back to the fishes. So it encompasses two types of agricultural product and bring from one nitrogen source. And it is extremely water efficient system because the water is being circulated. There is no wastage of water per se. And it, as I told you already, it does not require soil, and therefore it's not susceptible to any kind of soil-borne diseases. So hence we can cut off the pesticide application part, and these are basically organic. They are very organic. So yeah, as I was saying, they don't require any fertilizers or chemical pesticides, and they are very organic. And another very useful thing, they can be used on non-arable lands. Now, sometimes you have lands which are susceptible to a lot of salinity, maybe near the coast. There's a lot of salinity in the soil, and you cannot use the soil and for any kind of agricultural production. So we can go for this kind of aeroponics. So aeroponics, we can no aeroponics. I'm sorry, aquaponics, wherein we can grow the vegetables without being dependent on the land. So even we can grow them on sandy islands and deserts as such. And they create very little waste. Why? Because they mimic nature's circular approach. So the waste is used as nutrients by the plants, and that is again being filtered. The water is filtered and sent back to the fishes. And this is the most important point. This can integrate the livelihood strategies to secure the food and small income. So they can be sustainable ventures for many people. So wherein they can generate not only their sustenance, the food, the fish, and the vegetables, but also they can sell it to earn a handsome exchequer. Now coming to the cons, so this system it is it is an expensive system because it is energy dependent. We need to provide energy. We need to provide a pump. We need to provide a circulatory system for the water. So we have to invest initially on the system, and hence it requires the money. And it also requires expertise. So it requires expertise. We need to know what kind of plants would be suitable for what kind of fishes, how much ammonia is being secreted by the fishes, what is the pH, if there is an ammonia buildup in the tank, is my pump working effectively? So we need a little bit of technical expertise and to a little bit of knowledge of the plumbing and the wiring so that we can efficiently reroute the water that is being sent from the aquarium into our beds. And a little bit of mistakes, small mistakes, we need to manage them, and small mistakes can often lead to catastrophe in such a situation wherein the plants they can be deprived of some kind of nutrient and they may die, or even sometimes the fishes, there might be an ammonia buildup and the pumps may not effectively or efficiently clear all the water from the tanks, and this ammonia buildup can result in the death of the fishes. And so it also requires monitoring, stringent monitoring, and of course it is energy. It requires energy costs, and we also need to obtain the fish feed. The fish feed is very important, which we need to obtain on a regular basis. So that is the part wherein we are investing some money because we need to regularly generate the waste ammonia. For that, we need to regularly feed the fishes. And the products which come out of aquaponics, that is only the ammonia, is sometimes not enough to ensure a balanced diet to the plant. So the plant, as I told you, it requires macronutrients, it requires micronutrients like iron, copper, and all these are not available for the plants. So sometimes low nutrient rich plants, low nutrient demanding plants can survive aquaponics, but high nutrient demanding plants, it's very difficult for them. And often we can see the plant suffering from this lack of nutrients. Some of the symptoms of lack of nutrients do occur on plants which are under such system. Now, what is the importance? What is why we want to do aquaponics? So the importance of aquaponics, stems from our sustainable development goals, which were given to us by the United Nations, as Antonio Guterres, who is the United Nations Secretary General, he rightly points out that we have 17 sustainable development goals on which we need to work on. And the time frame for this was given out in 2015, and by 2030 we need to work on these. All the partner nations, whoever are in the United Nations organization, they need to work on these. And if in aquaponics, if you see, if you go for the point number 11 and the 12, that is sustainable citizen community. So we are, if we deploy such kind of systems, we deploy sustainable communities, which wherein we are growing the fishes, we are growing the vegetables, we are also not only drawing sustenance from them, we are also selling them from a profitable exchequer, and also responsible consumption and production. So there is responsible consumption and production. There is not extra consumption or wastage of any kind of product. So this is why we are doing it. So as my part in IBRAD, in Indian Institute of Biosocial Research and Development. So we are more basically uh, building up capacity building. We are working on that of villages. So what we do is when we assess the risks of these villages. When we are looking at the villages, we determine what kind of problems they are facing in generation of agriculture or fisheries maybe. For example, they don't have fisheries, or they don't have an organic setup. So what we want is we want to initiate certain kinds of setups like this aquaponic system or organic farming. So what we do is we assess the risks, we assess their current situation, and then we define the target and the policies. So we need to define the targets for like what we want to do. We want to fix certain policies we want to initiate, and then we implement. So implementation is where all this comes into play, where we go and talk to our stakeholders of how you can grow plants and fishes in a small place. For example, if they don't have land, they can grow it vertically, or if they want organic farming for their own sustenance, they can grow it. So implementation occurs, and then there is a measurement, and finally, we communicate to the stakeholders whether the process is viable or not. So this part is a bit of a management part. So this is how uh, all the sustainable development it's happening, how the sustainable development, the goals which we think about, for example, aquaponics and hydroponics, when we implement. So this is how it happens when we are talking about capacity building. So for this seminar, the take-home message for you all, and the take-home message will be that the plants, the fishes, they they eat and they produce feces, and this uneaten food and the feces, they produce ammonia, and this ammonia is converted into by the beneficial bacteria into the nitrates. So these nitrates are then absorbed by the plants, which then which have cleaned the water, and this water is being recirculated back into the system. So thank you all for listening, and I hope that will bring some clarity on aquaponics. Thank you.
Thank you very much, Dr. Datta. It was really insightful, informative, and it was simply amazing. So thank you so much for that, for your
Thank
time,
you.
for taking the effort to make our participants, understand and keep them engaged. So,
Let's
before
take the screenshots, Dr. Mukherjee.
so,
Yes.
some questions from the house, I would request all the panelists to kindly turn on their video so that we can take a quick screenshot for our record. Just kindly turn on only the panelists. If you guys can.
I think I cannot start the video because from the host side it has been stopped. So please,
Okay, just wait a
Pritam,
second. I'll
yes,
just
please look at it.
host. Yeah. Yeah, I think now you guys can.
Okay, I'm trying. Okay.
Yeah. Yeah, so I think now everybody can turn on their videos. Dr. Shaha and Dr. Ahmed. Okay. Okay, thank you, ma'am. So I would request all the participants to kindly post your questions in the chat box or in the Q&A box so that we can take them. And our expert speaker will then be able to answer them for you. So far, there are no questions.
One question, I have one question about Saurav Dhakta. That is, is it possible any brackish water fish culture that you are showing that Baramundi culture is possible over the aquaponic system, but is there any hampering in the vegetation because the saline water hamper the vegetation? So is there any problem to culture the sewage type fish over the aquaponic, or it is possible? So can you please take it?
Yes, yes. Aquaponic systems, they deploy a lot of freshwater fishes and freshwater systems. So they do, some systems have been deployed where Baramundi, as you said, correctly, have been used. But then again, it requires a stringent monitoring because, as I told you, the fishes and the plants, they're dependent on the pH. So the pH of the water is very important for the growth of the fishes and the plants. So if the pH of the water shifts, if there is more ammonia buildup in the water, and what happens is, as ammonia buildup in our human systems, so when ammonia buildup happens, so we go for organ failure happens, and the fishes also, they do gasp for air and they do die. So it is very difficult to do certain kind of aquaponics in the salty water. Most of the systems, they prefer fresh water and freshwater fishes. But yeah, it is possible. It has been done.
Okay, thank you very much.
Mhm.
Dr. Datta, like I'm just curious to know how much prospect we have. I mean, we know there are a lot of prospect from the industry point of view, but how much research is actually happening to even further enhance this technique?
Yes, yes, Dr. Kidam. The technique is there. The technique, as I told you, it has been developed, and also the system like Aeroponics, which was developed by NASA for supplying fresh vegetables to their astronauts, that has been developed. And on this technique, now what people are doing, the research part is when we are thinking of a very simplified system where we are supplying the plants only with the water which is runoff from the fish aquarium, and that is supplying the nutrients to the plants. But is that enough for the plants? The plant, sometimes it is not enough. It does not get all the macronutrients. So as I told you, the NPK, the macronutrients, the iron, the molybdenum, it does not come from this thing. So what happens is that part is where the research starts. So nowadays, the research, what is going on in aquaponics is what does the deficiency of certain micronutrients or macronutrients lead to in the plants, or what is the most effective way in which we can supply the nutrients to the plants. Of course, we can give foliar fertilization, but that does not solve the purpose. That does not make it sustainable. So to make it sustainable, also we need to work on the fish feed. The fish feed also needs to be enhanced so that it can supply not only the fish with all the required nutrients, but it can also supply the plants with the required nutrients. So I hope that answers your question.
Yeah, I think so. I think, yeah, as you said, I think the use of probiotics and I mean for the fish feed and maybe use of biofertilizers using microbes like, which can promote the growth of plants will be useful.
Not only microbes, even worms, certain
Even
worms can be used. So that and all is a lucrative area of research if you're looking from a research point of view. And from a commercial point of view, if you want, it's a very basic setup. As you can see, it involves only three things: the equipments, the energy, and the organic parts, which is the fish and the plant.
Yeah, thank you. And one more question, like if anybody wants to start a startup, like how much how much will be the initial cost involved in this process?
Yeah, if you want to start it up on a commercial scale, if it is on a commercial scale, when we're talking of startup, we are usually thinking of commercial, otherwise it's a pilot experiment. So we're not talking about a pilot experiment. A pilot experiment can be done on your local aquarium, which you have at your house with a tray, with a plastic tray, you can do that. But if you're planning to do it on a commercial scale, it is going to cost you around 5 lakhs to start up a system. So the initial startup cost is high. And as I told you, the fishes, as I've shown, the fishes also require some time to grow up. So that is a period of 1 year. So we need to hold tight for the 1 year before we can expect any kind of returns.
Yeah, thank you. And I really like the idea of using solar panels, like to save energy consumption.
Yes, that is also in research.
Yeah, I know. Yeah. Thank you so much, Dr. Datta. I think we don't have any other questions. I can't see any. So with that, we'll end the session, the presentation session. So now I would request our very own Mr. Pavel Visas, who is a research scholar in the Department of Oceanography, Technical University, West Bengal, to deliver the vote of thanks. Over to you, Pavel.
Now this is the time of vote of thanks, and I am really very much grateful to the organizer to give me the opportunity to delivering the vote of thanks. And firstly, the Dr. Abhijit Mitra, with the quote of Dr. Abhijit Mitra, that we have to make more practice with our related fields, so we can make a sustainable project and a sustainable program. So Dr. Abhijit Mitra, who is the pioneer scientist in the field of carbon sequestration, especially in mangrove vegetation, and working lots of projects over the national and international project related to the environmental issue, and foremost think about the alternative and sustainable livelihood. And after that, Mr. Datta is very much passionate about his work and always motivate us towards the creating novel, futuristic, innovative project. That is all. And I think it is a very great startup webinar, and all the participants are hopefully enjoy this presentation very well. And now I would like to thank Dr. Abhijit Mitra, who is the research scholar, research dean, Technical University, Dr. Ila Palodi ma'am, research dean, Technical University, Dr. Sufia Jaman, head of the department of Technical University, Dr. Sampanik, faculty of Technical University, Dr. Brahmanik, faculty of Dr. Pritam Mukherjee, faculty of Economics, and Dr. Orbita Shah. Thank you. And over to you, Dr.
Yeah, thank you, Pavel, for your vote of thanks. So now it's time to end the program. So thank you, dear participants, for registering and attending this webinar, and everyone else for your cooperation and patient hearing. So the next IIC event session on innovation will be held on 4th of July 2022, like in 2 days' time. And the expert talk will be delivered by Dr. Rajrupa Ghosh. Dr. Ghosh will emphasize on converting innovation into a startup. So I look forward to your active participation. Good night and stay healthy and safe. Thank you so much.
Yes, thank you all.
Thank you all. Thank you, ma'am.
Yeah, thanks everyone.
Thanks, everyone.
Thank you.